So I'll introduce Camilla. So she's from Norway, in a company called Kyoto. And it's actually one of the companies who were part of one of our clean energy programs, the Alliance.
Thank you, Magnus. My name is Camilla. I am Swedish, Magnus, but I represent a Norwegian company called Kyoto. So, and I lived in Norway for too long, so my dialect is svorsk. We're going to stay in the energy field. This is us, this is Kyoto. Our mission is to empower industry with clean heat. And in a world powered by nature, meaning with intermittent sources of energy, enabled by people and assisted by AI. So that's what I'm going to take you through. I am sad to use this first slide. I'm a little bit tired of using this first slide because as society as a large, we are not reacting to this message. But the message is brutal. We met 2 degrees in November, one day in November. We have one of the world leaders telling us that humanity has opened the gates to hell. And as a society at large, we are not reacting to this. I have to use this slide because we are reacting to the color red in this. So what I'm going to present today is that we have a technology that is readily available to be scaled up at speed, which with the potential to have a significant impact on this. But what is that? Half of the energy demand in the world is heat. And that is almost entirely produced by fossil fuels today. 90% is produced by fossil fuels. And this is readily possible to electrify today. A significant part of it. If you look at the industry, 2/3 of the energy demand from the industry is heat. The industry needs process heat to form things and to clean things and to shape things. And in every factory around the world is 1 or 2 or 3 or 5 gas boilers today, delivering this heat to the industry. In pulp and paper, in chemicals and pharmacy, in iron and steel, in food processing, in beverage, everywhere we find this industrial process heat produced by fossil fuels. And we can change it today, and we are not doing it. So it's a significant low-hanging fruit that we can react to as a society. And this is what our technology is doing. And we are working a lot with the energy department at KTH for the further long-term development of this technology. But what is it? If we need heat at the end, and we need to balance that because the sources of energy is intermittent. We cannot control it. So we need something in between the heat and the solar and the wind that we have heard about. And then we need the only thing that makes sense if the end demand is heat is to store it as heat. That's a fraction of the cost of comparing it to electricity, around 25%. So we don't need electrical batteries for all this energy demand. We can store it as heat at a much, much cheaper cost. And this is what our technology is. So we are in between the factory that needs the heat and the solar that we don't control. And how do we do that? It's a flexible asset that absorbs electricity when it is available or when it is really cheap on the electricity and holds it until the industry needs it. And we are doing that by using an electrical heater, heating up molten salt, nitrates, which is a fertilizer product that we buy from one of the largest fertilizer companies in the world. And then we deliver it as steam to the industry. And this is how the current version looks. So this is installed at site, absorbing the electricity when needed and delivering often continuously to the industry because the industry needs a high quality, stable delivery of steam. So then we have made a product out of this, a standardized product, which allows us to scale this quickly. And we have then modules, the heater, the tanks that store the salt, and the steam generator. And then we build this together with the plant, depending on how much storage do you need. Are you in Spain? Do you have 10 hours of renewable electricity during the day that you can trust that you're going to have? Or are you in Denmark and you have every now and then, you have cheap electricity on the grid from the offshore wind, and often negative hours. Often during the night in Denmark, we can get paid to charge the battery. So then we design this together with the industry in a modular way, meaning that from the day we sign with the customer, we can deliver a battery in about 1 year. Then we deliver a turnkey solution, which is a plug and play to the existing gas boiler. We plug into the same steam pipe in the industry and replace the gas boiler. This is how it looks. We are also connecting this to an AI-powered data ops platform. So this battery needs to be smart because it needs to know when to charge, and it needs to plan a little bit in ahead when to charge. And we have foresight to the electricity prices the day after on the grid, but we need to balance those two. We need to balance when the industry needs the heat and when we need to do predictive and preventive maintenance, and when we need to charge. So this is what we are using an AI-powered data ops platform to do. This is a study done by McKinsey comparing different technologies. What options do the industry have when they need to replace the gas, which they need to do because we are phasing out that over the next couple of decades. You can look into a biomass boiler. You can look into an L boiler where you connect an electrical battery and then you produce the steam with an L boiler. But none of these reach the cost, the OPEX cost of running this. On the right-hand side, you see an electrical boiler with thermal energy storage, which is what we are doing, thermal energy storage, delivering a boiler. And then you can also do this with a heat pump, but then you come to the 150 degrees, maybe a little bit higher, but you're not able to reach the higher temperatures that the industry need. But the trick here is the storage. You need to deliver a solution that can absorb the volatility of the renewable electricity and at the same time utilize the very cheap prices of that. It is becoming an increasingly painful problem for electricity utilities in Europe when we see the installation of the PVs, which we saw just previously, because more and more hours are stuck in the middle of the day. They have too much production and the utilities don't get paid for that. And that pain is starting to be felt now, before the major scale up and ramp up have started. So the utilities in Europe is waking up to this now, and how do we move and load shift this electricity? So that's the three value propositions with thermal energy storage solution like ours. We do the load shifting. We utilize the electricity whenever it's too much on the grid or whenever it is available from an off-grid installation. It reduces the CO2 emission from the plant and the costs related to that, because that is also becoming increasingly painful for the industry to pay for the CO2. One battery, a standard battery, is what we call a 64 megawatt hour battery. That is a very typical size of an industry. One battery corresponds 5,500 cars, to replace 5,500 cars. So it's a significant impact to roll out this technology. And then, of course, that grid balancing is a value proposition for the TSO and the DSO to balance that overproduction and load shift that. If you look into this, it's close to 1,000 billion euro to replace all those gas boilers in the next decades. For us, we have converted this to number of installations. So to replace all those gas boilers in the industry, we need around 370,000 installations of thermal energy storage at industrial sites around the world. And this is where we have now positioned ourselves to scale. We are mainly a supply chain orchestrator. We have teamed up with the best in the world. To this, you will find Iberdrola, which is one of the world's largest electricity utilities, who is bringing this to the market together with us. We're working with KTH on developing this technology further, with Cognite on the data powered AI platform in the backend, and Schneider Electric to bring all the electrical things needed for the heat cube. So this is our company, and this is where we are, ready to bring this to the market.
Wonderful,
you.
Camilla. It's a wonderful story. Do you have any questions for Camilla?
I do. We can start with you.
Yeah, what about calculation of the cost? Where you have the current state where you can buy or actually get energy for free, as it's no demand. But if you install this on a scale, then you create the demand that raises the cost. You won't get the free energy slots as you create the demand.
Yeah, and that.
Well,
Can you repeat the question, because otherwise the guys don't hear.
Yeah, okay. So I think the question is, you're going to increase the electricity demand, and that's going to increase the prices. Yeah, exactly. And it's actually not going to do, because the electricity is stuck today. So the utilities, they have too much production in the middle of the day, which they today don't get paid for. They are not storing it. Yeah. So we take care of those hours. So
yeah, but if you install your solution on a scale,
yeah,
then you will create a continuous demand.
yes.
And then the cost will raise.
Yeah, yeah, but it will not raise at a system level, because you are just moving it. So it's actually utilizing hours that you get these hours very cheap from the utilities, because otherwise they wouldn't get paid for it. And their main problem today, if you ask a CEO of a utility, their main problem is to increase electricity demand, because we are electrifying the society. So we want to increase, but by utilizing the system differently.
Well, then another question, or?
There's a comment from online that there's a ESG program where Willem is happy to introduce you to some good context.
Fantastic. Maybe you help me connect.
Yeah.
Yeah.
Super, thank you so much, Camilla.
Thank you.